Thanks for joining. Today is day number 3 for our EI journey, and today I am going to cover VLAN trunks, EtherChannel, those theory with lab. So let's start. We know that the usefulness of VLAN, virtual LAN. What is the use of this VLAN? Can you tell me the use of VLAN? Why we are using it?
So we use VLAN to break down broadcast domain, right?
Yeah, 100% right here. And we can create multiple VLANs. So multiple VLANs, they have their own network. Maybe VLAN 2000, 2001. So IPs and gateway in those broadcast domains obviously will be different and all. Now, what are the methods that we can go and create the VLANs? So we can go and create the VLAN like manual assignment. Manually, we can go and create the VLAN to, suppose if I have 10 switches, so all the switches I can go and create VLAN 2000, 2001, etc. Or we have option that we can go and use some sort of uh, VLAN trunking protocol, VTP type of protocol, that in one switch, if it is a server, VTP mode server, where we can go and create the VLAN database, and the VTP mode clients, they can go and where they can be replicated. So we may have VTP in client server mode, switches which are server, they have this authority that they can create, edit, store the VLAN information, and the client end they can receive those VLAN updates, the revision updates, and according to that they can update their VLAN database. So there is one protocol. Then you can see that a DTP is there, Ether channel is there. So one by one we'll go and check. VTP, this is a Cisco proprietary protocol to reduce the burden of writing the VLAN information to all the switches. There you can go and create, you can see that we have the modes, server, client, transparent. Server, where you can go and create, you can say create, modify, delete the VLANs database. Client is there that can receive the VTP advertisements with this VLAN information, and they can have the same VLAN information in client as well. Whereas one other mode is there that is transparent, that will receive and forward the VTP advertisement but do not modify the VLAN database. So it will receive and can forward the VLAN information, but it will not create or modify the database. Then off means you want to do create all the VLANs manually. In BTP we have version 1, version 2. In previous examples, we have this VTP creation over the switches. So VTP maybe VTP mode 3, where you can put some password as well. This is little bit more secure than 1 and 2. So VTP, and then you can assign some password. But overall logic is this, that this is there to do some sort of auto configuration for the VLANs. So if you have big database, suppose if you have 500 VLANs in a switch, and then suppose if you have 200 switches in a network, then 500 into 200, these many times you have to log into the switch and create the VLANs manually, and there may be chances that someone can miss some VLANs. So there are pros, but there are cons as well with this VTP, that in between, if someone can go and become the VTP server and he can go and manipulate the VLANs, then all the VLANs within the network will get corrupted. So there are good thing, there are bad thing with VTP. We are using it, but if we are using it, we should use it with caution. Here you can see one example where we have the VTP domain name. You have to define the domain name, then VTP version. If this is VTP mode server, so servers can, let me highlight the VTP mode server. You can see the, oops, you can see the password. So you can see first create the VTP domain, version, suppose mode is server, you can give and assign the password. This is the VTP primary, then again it will ask for the password. Then switch number 2, you can see that VTP version 3, this is client, VTP password. And like switch 3, they are transparent. So all these three examples are there, that you can create the server, you can create the client, you may have the transparent mode. Right, easy and straightforward. There is nothing much that we can enhance more on this. It's easy. Once you have the VLAN database as per the BTP client and server and client configuration, it will get replicated to the other switches. Now next we have this dynamic trunking protocol. DTP are established by the switch port sending DTP packets to negotiate whether the other end can have the trunk port. This is used for the trunk port negotiation, and it is sending their packet after every 30 seconds. DTP requires that VTP domain match between the two switches. So for DTP, it is required that your VTP domain is correct, because when you are creating the VTP, first of all, you have to go and create the VTP domain. So for example, in this switch, I have VTP domain Cisco Press. It should be there in all the switches, Cisco Press everywhere. Then this DTP will work. Now here you can see that DTP has the mode. What mode it has? Trunk. Trunk means what? Trunk means that you can pass multiple VLANs straight away. So one side is trunk, other side is trunk. That will be the trunk. Then it may be dynamic desirable. Dynamic desirable. So here you can see this list. No need to go one by one. Here you can see one side trunk, other side dynamic desirable, other side dynamic desirable. It will become trunk. One side dynamic desirable, other side trunk. It will become trunk. One side dynamic desirable, other side dynamic desirable, it will become trunk. One side DD, other side dynamic auto, it will become trunk. But only one corner case here, that one side if you have dynamic desirable mode, DTP mode dynamic auto, one side if you have DTP mode dynamic auto, other side also you have DTP mode dynamic auto, it will not become trunk. It will not negotiate as a trunk. That is the only one case. Otherwise, in all the use cases, we can see that receiving and sending switches, if they have the dynamic desirable trunk dynamic auto, they will become the trunk, except only one use case, that if both the switches are running DTP protocol as a dynamic auto, then they will not form the trunk. You can see here the configuration. Dynamic auto, one side dynamic auto, if other side also you have dynamic auto, they will not form the trunk. But auto with desirable form the trunk, desirable with desirable with form the trunk, trunk and trunk is obviously the trunk. Right, then you can go and check the interface trunk and all those configuration that we have already checked this. If you want, you can go and turn off the DTP switch port and non-negotiate, then it will not negotiate the DTPs, right? It will not make this automatically trunk. So far, if you have any question, query, please feel free to ask.
No question, sir. No question.
All right, now let's come to this Ether channel. Ether channel, I like this bundle channel or Ether channel concept, because not only it can be bundled with switch to switch, but you can go and bundle this with some server as well. We know that we want to aggregate the links or bundle the links. Why? Because we want the overall extra enhancement or overall throughput, right? So suppose if we have requirement of 2 gig of throughput within the switches, but you have only 1 gig interface connected, then what you will do? You have to go and bundle these interfaces. There is no other option. Tomorrow, if I have 4 gig overall requirement, then what I have to do? Then we have to go and bundle the 4 interfaces. Then only it will become the 4 gig. This is true in between switch to switch, and this concept is true with the switch to servers as well. Sometimes we want high throughput in between the servers and the switches. So there also we are bundling the interfaces, right? So this is the concept of bundling the port. This is also easy and straightforward. But here you will see that while we are bundling the ports, you can see link A, link B, DTP, DTP. While we are bundling the ports, we have multiple protocols that is supporting this particular configuration. We have Cisco proprietary protocol, PAGP. We have industry standard protocol, that is link aggregation control protocol, LACP. And if we don't want to use the, I can see the LACP and PAGP. So here we will see that port aggregation protocol PAGP, link aggregation control protocol, that is LACP, LACP PAGP. There are some use cases why to use PAGP or LACP. Generally, people are using LACP because this is industry standard and this is highly tunable link aggregation type of protocol, right? So even we are also using, mostly we are using LACP, and probably in your EI exam also you have this LACP that you have to configure, right? To bundle the ports. But there is one other mode as well, that you don't want to run any protocol. So maybe that if you have your switch that is connected with server, right? That server don't know LACP, that server don't know PAGP. Then what you can do, you can go and link them manually. So on that case, the channel group mode is on. So actually there are three modes for this aggregation. The channel group modes are, either you can go and use LACP, active, passive, PAGP, PAGP, desirable, or something is there, we'll see that. And on, mode is on, mode is on. Like that you have the modes. Generally, we are using this on mode or LACP. Mostly you will see these things will be used, right? In our lab, we are going to use LACP, flat LACP. Yeah, you can see desirable and auto, desirable and auto. If both side desirable, it will form the bundle. If one side auto, other side is also auto, it will not form the bundle. One side auto, other side desirable, it will form the port channel or the bundle. Likewise, if both side active, it will form the port channel. If both side passive, they will not form the port channel, but one side active, other side passive, it will form the port channel. And then you can see this is the summary side. This is important. A static ether channel. If mode is on, they will form the ether channel. In case of LACP, we have mode active, passive. Both side passive, it will not form the ether channel. At least one side you need active, other side may be active or passive, it will form the port channel. Likewise, we have auto and desirable. Both side auto will not form the port channel. Desirable auto will form the port channel. Desirable and desirable will form the port channel. Right. So PAGP will be used very less, so I will not go on that much detail. Uh, Here you can see that the example related to this. I'm also going to show you the example in the switches. LACP having some other features as well, like port channel, minimum link, maximum bundle, and all those things. That's why mostly people are using this type of configuration. LACP fast is also there, that we can go and tune the LACP timers. So LACP rate fast, that if any happening is there, mishappening is there, it will trigger the alarm. Then you can go and check the minimum or maximum, the maximum link members that will be formed with the LACP. Again, I told you that LACP is something which is highly tunable. You have so many other extra features with LACP that people are using, and that's why LACP is used. Okay. Then finally, you can see that we have the port channel bundling methods, that we can go and use the load balance method with the port channel. And we have methods that we can go and use the destination IP, destination MAC, destination mix IP port, and destination port, and all those option. and you can bundle it. By default, obviously, it has some default method, but we can go and check the port channel load balance method. Once we go and enable this, we will see what is by default, what is running. But you will see that when they are bundling the method, they can forward the packets as per these combinations. And even we have option that we can go and choose these options. By default, it may be something like source, destination, IP or MAC, but we can go and manually assign these roles. Okay, let's quickly see that in our topology, what type of topology we have. So in one of the headquarters, we'll see that there are switches connected. So switch 1, switch 2, switch 3, where you have to go and fix the port channel. You have to make sure that all the port channels, they are working properly. That means you have to do little bit of troubleshooting and make sure that everything is up and running. So you have such type of connectivity, right, where you have to fix the port channel. And then this is port channel 1, port channel 2, port channel 3. I'll write it. This is switch number, for example, 110. This is switch number 101. And this is switch number 102. This is suppose port channel 1. This is port channel 2. And this is port channel 3. 1, 2, 3, right? Now we have to go and check the interfaces that is connected. Um, Obviously, if you have diagram, you'll come to know what interfaces are there. For example, here I have interfaces E1 slash 2 and 3. And likewise here also I have interface E1 slash 2 and 3. Here also you have interface E1 slash 2 to 3. And here also you have interface E1 slash suppose 0 to 1. So 0, 1, uh, 0, 1 slash 0, 1 slash 1, 1 slash 2, 3. So 0, 1, 2, 3. Here you have 2, 3. Here you have 2, 3. And likewise here you have interface E. For example, 2 slash 0 to 1, both sides. E 2 slash 0 to 1. Like that you have the, oops, you have the interfaces that you have to make sure that all these interfaces, support channels are up and running, they are working fine. So here if you go, you can see the switches and diagram is there. So switch number 101, if I can go and check, show ether channel summary. You will see that I have port channel 1, port channel 3, right? Now with this output, what you can figure out? What's the issue? Here, you're with me?
So on port channel 1, you don't have a interface as you don't have a protocol and a port number specified.
And port channel 3?
And then port channel 3, it looks like you only have you have port 1 and port 0 on port channel 3. That's what you have there. So are the two ports that bundled together, or are two separate ports?
Yeah, so port channel 3, you're right, that 20 and 21. You can see the diagram as well. 20
Yeah,
and
they are
21.
bundled together.
And what
But
type of port channel is this?
this is LSCP.
Protocol is
Port
LSCP,
channel
right?
3, port channel 3 is LSCP. Port channel 1 is not defined. We don't have
Yeah.
no.
So what does it mean by P?
Um, tell me, I forgot.
You can see here that the bundle
Oh
in port
yeah,
channel.
yeah,
So
port bundle.
yeah, if we have this R, it will be layer 3 port channel. If it will be SU, you can see U here. So SU, U means use, but if it is SU, that means switched. This is layer 2. This is layer 2 port channel.
Layer
But
two
if you
port
can,
channel. Okay.
yeah, if you can go and assign IP address to port channel, it will become layer 3 port channel. Then it will show you RU.
Okay, got
Okay.
it.
So you can see the group number here. Then you can see port channel is layer 2 in use. The protocol is LSCP and they are up and running, right? They are up. Otherwise, you will see some down messages. We'll see that down as well. So if I go here to switch 110, if I do show ether channel summary, you will see down.
Okay.
What is this small s and y? So with this output, what you can figure out? What is your understanding with this output?
That one, port channel one, is not running any protocol. I don't see whether it's running LSCP or PAGP, but interface 0 and 1 is a two port that was bundled, and it is down on port channel 1. Port channel 2 is running LSCP, and interface 2 and 1 is on 2 and 3 is on port channel 2, but from a local things it says S, and what S stands for? S mean what? S, it means that it's suspended.
Yeah. And what may be the reason that it is suspended?
What do you think? I don't
Maybe
know,
interface
honestly.
down, maybe not configured properly and all. And what does it
Okay.
mean by this dash,
I
protocol
don't know.
dash? That
I
means
don't
it is
know.
not running any protocol. So three modes are there, right? LSCP, PAGP, and on.
Okay.
Let's see. If I go to this particular interface that is E1/0, you'll see channel group mode is on.
It's on. Okay.
Right. So as per the question, we have one requirement that we don't want this method on. What we want to make this as a LSCP, mode LSCP, right? So what we
Mm-hmm.
can do, we can go to interface range E1/0 to 1, and then we can do no channel group, right? That means that is gone. Then we can do channel group 1 mode either active or passive. So
Uh-huh.
if I go other side, what is connected to other side with port channel 1? You can see the diagram. Switch 101 interface 1/2. So if I go here and check show run interface E 1/2. Oh, here you don't have any configuration. 1/2 and 1/2 and 3. You don't have any configuration, right? So that means we have to configure it both the sides.
Yeah,
So
it looks like there's no port channel bundle over there, so we gotta do it again. So
so
passive and
if I
then
go do passive here, then this side surely I have to do active, right? So interface range E 1/2 to 3, and channel group should maybe it may be different number as well. It's just a number, but anyways, channel group 1 and mode I have to give active, right? So one side active, other side passive will work, or both side active active will work, right? But passive passive, if you do passive passive, that will not work, right? That's the logic. So one side active, other side passive, that means it should go and form the port channel. Now let's see, do show ether channel summary. We are focusing on this part at the moment. No, still you will see that it is showing down the port channel one. Just focus on port channel 1. So L2, max port 2, ports, max channels, etc., etc. But you will see that this is something that is down. So what you can do, and this is the troubleshooting that we need to do. We have to force start these interfaces. So you can go to port channel 1, do shut and no shut. And
Uh-huh.
then if you go and check the summary, you will see now it is in waiting state.
So
Waiting.
the other side has to be turned on too, right?
Yeah, waiting for aggregated. One side also you can force a start. Now you can see it is in suspended mode. Now you will see that it is in suspended mode. You can see S stand for suspended, small s. Now you will see that it will take some time, maybe 30 seconds. But after 30 seconds, now you can see that one is suspended, other one is H. H is what? Hot standby. And then finally you will see that now one is up, right? P, and other one is waiting. Again it will move to hot standby or something, hot standby. Now you can see that both the port channel means the member interfaces within the port channel, they are up and running, right? So one side we have fixed this issue. Now if I go to this switch number 101, what port channels we are expecting as per the diagram, you will see that we have port channel 1 and 3. Seems that it got stuck. Seems the lab got stuck. Okay, no problem. I'll fix it. So far, if you have any doubt, any problem, please feel free to ask. So what is our goal? Our goal is that we should bring these port channels up and running. You can see the diagram in the back. Once they are up and running, then we can fix the issues and all those things, right? So now again, if you go and check show ether channel summary, you'll see that it is down and all because we have reverted the lab. And let me go a little bit up here and just configure this. Easy interface range E 1/223 channel group 1 mode active. That's it. And then we can go and check do show ether channel summary. You'll see that it will become one ether channel is already up. This is in waiting state because other side we don't have proper configuration. So we can go to the other side. Interface range E 1/021 no channel group. Then we can go and do channel group 1 mode passive, active passive, anything will work. Then can go to port channel 1 shut and no shut. It will take some time to come up. Meanwhile, we can go to interface range E1/223. This is E123 here, where we have to go and run channel group 2 mode passive. You can do no problem. So now you have the configuration. You can see the configuration for E10 and you can see the configuration for 2 as well. One place you have channel group 2, one place you have channel group 1. Now we can go here to this particular switch. We can check this summary. Now you can see both are up. Now you can go to switch 110 ether channel summary to show ether channel summary. You will see that one is up, one is down. One is up, one is down. This is down. Why? Because this side you have to fix. So if you go to this particular switch and see the configuration over 1/2, you'll see that it has some passive channel group 2 mode passive that you need to correct. So you can go to interface range E 1/223, make no channel group. Then you can do this channel group 2 mode active because the other side you have made this passive. And then if you go and check do show ether channel summary, you will see that your Port channel 2 and 3, they are up. If you can go here and see your port channel 1 and 2 up, port channel. So now you have fixed the port channel issue in all those switches, corrected the methods of negotiation, everything is up and running. Right now, if you have some verification things that you want to do, you can do it. So here we are, if we go to LSCP, port priority, 1, exit or end, we can go to check show ether channel, load balance, see that load balance method IPv4, you can see it is using, by default it is using load balance method shows destination IP. These things you can change, right? So you can go to the interfaces ranges and load balance. What are the options we have? See, I don't know how we can go and change the load balance. Because this much only you have to do, right? But yeah, in your real scenarios, if you have to go and tune something like load balance method, maximum link, and all those things, then you can go and check certain more options over the interfaces. Both in the Nexus switch and iOS switches, you have those options that you can go and choose and you can change. You know that there are
You
lot
say
of options.
you said in the Nexus switches, what we have there?
Nexus switches also we have these options, right? Nexus, Juniper, Cisco, all the switches we have
Yeah.
this
So
load balance.
okay, you still recording?
Yes, I'm recording
Okay.
this. You can see you can go to global mode, port channel load balance option. You can see source destination MAC if I do, and if I go and do show ether channel load balance. So you can see that method become source destination MAC. Earlier it was source destination IP. Like that you have these options as per the requirement. Sometimes we have these requirements that we have to change the balancing method as per the application requirement. So we can go and change it as per the requirement. Sometimes it is MAC based bundling, sometimes it is IP based bundling, sometimes mix of bundling. Sometimes we have some port numbers like UDP and TCP, etc. Like so many options are there because this is normal small EVNG type of image. You're not seeing more options, but there are good options that you can check there in this slide, presentation slide. If you have any question, please feel free to ask. Yeah, you have any query?
No question.
All right, so if we go here and check, so LSCP, you can say neighbor ID, internal, blah, blah, all those things. If I can go and check the ether channel, what other options we have? Load balance, you check that. Details, I can go and check. Protocol, we are running LSCP, so it will tell you LSCP, blah, blah. Then if you can go and check the details, port channel 1, group code, okay. Okay, and it is telling about member interfaces, number of ports to logical slot 16/1 and show ether channel. You can see this group is L2, max port 4, ports we are using 2, like that. Now what about that if we can go, so we have port channel 1 and add more interfaces in this. You can see that max bundle command is there. LS maximum number of ports to be bundled in this port. If I type question mark in this iOS, it is supporting 8. So in the bundle, I can create 8, max 8 ports I can bundle. So like that, you can go and change the configuration item like this. Okay, so these are the knowledge information about the LSCP. PAGP anyways, we are not running. And if both sides, if you are running on, so for example, if I can go to interface range E 1/223 and I'll do no channel group. What is that channel group? 1. Even remove that. And then I can go to channel group 1 mode on. I have to do this both the sides. So this side also I have to go to interface range E1/0 to 1 and no channel group. And then I have to go to channel group 1 mode on. Both sides you have to give on. Otherwise, it will not form, right? Now, if you want to verify this, you can go and do show ether channel summary. You'll see that there is no protocol associated, but they are up. Likewise, if you can go here and check, do show ether channel summary. No protocol associated because this is manual method, but this is up. Like that, you can practice.